everybody is doing something with AI. So why not give it a try for ontology development? Our project got underway when we asked this question as we were working on a new ontology for a domain without ontologies, the domain of solitude. We decided to explore what AI in the form of ChatGPT could tell us about this new ontology domain, and this is the story of our exploration. The context for our work, as Ben mentioned, is within the Phases project, the title of which is Promoting Healthy Aging Through Semantic Enrichment of Solitude Research. The Python applications, data structures, and manual procedures used to explore this use of ChatGPT was given the name OntoChimp. OntoChimp is a ChatGPT-based concept extraction resource for ontology development. So, first, I would like to consider why we are interested in doing this. To understand the nature of a new domain, it's important to get a comprehensive catalog of the key concepts that exist within that domain. Achieving this with manual extraction is labor-intensive, inconsistent, and requires the use of valuable subject matter experts. OntoChimp is an evolving system that provides a semi-automated NLP-based approach to utilizing ChatGPT for ontology development. The overall workflow within OntoChimp is really divided into two workflows. The first to extract key concepts, and the second to categorize them. Workflow one begins with a reference set of carefully selected reference documents that span the domain of interest. We then pass each document to ChatGPT Application Program Interface, or API, to extract key concepts from each document. The ChatGPT API is sent a prompt with a short, simple request for key concepts, returning the results in a JSON formatted text response. We do not define what we mean by key concept. We simply let ChatGPT tell us what it comes up with as key concepts. The key concepts for each document are then stored in an Excel workbook. Note that we also ask ChatGPT for term clusters, and these are stored but are not currently processed. The application of workflow one in our Solitude study involved processing each of 29 chapters of the 2021 reference book that we use, the Handbook of Solitude. Our project is fortunate to have one of the authors of that handbook on as our subject matter expert for solitude. Each document was processed individually, producing a workbook of key concepts, which was then merged into the main repository for the project, the OntoChimp term table. This term table contained 506 distinct solitude-related key concept terms, 90% of which were multi-word phrases rather than single words. Multi-word phrases present special challenges. The term table warrants attention as it contains not only the key concept terms, but also the metadata about each term. Each term is assigned a unique 10-character hash ID that becomes the dictionary key. Each term is lemmatized into a standard form with lowercase, singular nouns, and verbs converted to their infinitive form. However, each as-read term is also stored so that a capitalized term and its lowercase equivalent are stored, but they are represented by the same lemmatized term. Additionally, the SPACY, that is SPACY, Natural Language Processing System, is used to identify a head token for each term, such as isolation is the head term for social isolation. Also, each token's part of speech, such as a noun or adjective, is recorded. Also within this terms table are subdirectories with hash ID as a key, showing other types of information, for instance, the list of document identifiers in which a key concept appears. Workflow 2 is a combination of manual processes and applications that are in development to characterize each concept in the term table and assign it a disposition code. One of the first steps is to compare each concept to existing ontologies related to the target ontology. We use for this the Bioportal Annotator API service, and also we've used the search service. We use both of them. However, a concern with that is that it tends to match one token, one word in the phrase, not necessarily the head token. So we are also working to develop a custom similarity matching application for multi-word phrases called Head First that produces a similarity score based on the head token similarity. These automated processes to categorize a term and assign it a disposition are not currently well enough developed to eliminate a substantial amount of manual processing. The workflow 2 categorization process remains largely manual, but we are working to improve the automatic characterization. In particular, exact term matches may be found automatically. For instance, the Bioportal Annotator identified 14 exact matching terms in the Behavior Change Intervention Ontology, BCIO, and 10 matches in the Emotion Ontology, MFO-EM. Currently, 24 disposition codes are now in our list, and new codes can readily be assigned that are applicable to a specific target ontology or new ontology development. The categorization table has the goal of assigning every key concept a disposition code, some of which are shown here. For instance, the INTO exact code is for a term that is in the target ontology with an exact match. For instance, solitude is an exact match, and it's already in the target ontology, which in this case is the phases solitude ontology. The INOO term is used for a term that is in some other ontology, and such terms may either be included, such as introversion, as in the emotion ontology, or excluded, such as public policy in the BCIO ontology, which may be too generic to include in the solitude ontology. An unexpected finding from this exercise was seeing that loneliness was not in the emotion ontology, MFO-EM. We contacted the maintainers of this ontology, and they added both loneliness and feeling lonely to the emotion ontology. While our results are still preliminary, we have identified 506 key concept terms from the 29 chapters of the Handbook of Solitude. Many of these terms are novel or underrepresented, with some terms appearing only a few times or maybe just once, but are considered by ChatGPT to be significant. The multitude of these concepts attest to the richness of the solitude-related research. Our problem is really how to call this list of concepts to those that need to be seriously considered by the subject matter experts as candidates for the ontology. The modular workflows allow OntoChip to be applied in any domain. A trial use in the domain of vaccines yielded good results identifying 11 terms that could be added to the vaccine ontology, a very mature ontology, but still had room for some additions. We're filling in the gaps with OntoChip. Our future work includes incorporation of the cluster terms, which may assist in automating the categorization process. We're working to improve the automated disposition assignments, and as this becomes more systematized, we hope to incorporate these dispositions into the term table itself. With a bit more refinement, we will work with subject matter experts and ontologists to integrate the key concepts into the emerging phases solitude ontology. Our Python applications are available in their current very developmental state at the temporary GitHub shown. In summary, OntoChip bridges AI text analysis with ontology engineering. It is a reproducible framework for ontology term discovery. Additionally, the term table data structure may prove useful for any project needing to process multi-word phrases. As the system is enhanced, we hope to demonstrate scalable, semi-automated concept identification, categorization, and term validation workflows. I would like to thank ASEA and the ICBO conference organizers and Finn for this opportunity to share our work. We appreciate the work of our collaborators, such as the maintainers of the emotion ontology, for their assistance. I would also like to acknowledge my talented colleagues working on the phases project, promoting healthy aging through semantic enrichment of solitude research. And thank you for watching.